Today we're starting a new unit about circles, so we're not going to be working with trigonometry anymore. This is activity 24, tangents and chords, and these words have to do with circles. We're working on lesson 24-1, just some introductory basics about circles. Learning goals are to describe relationships among tangents and radii of a circle, and to use arcs, chords, and diameters of a circle. First, let's define a circle. We know what a circle looks like. Everybody has a mental image of a circle, but here's the definition of the word. A circle is the set of all points in a plane at a given distance from a given point in the plane. When you draw lines and segments near a circle, these have special names. These first two drawings illustrate what a tangent line looks like. So notice the tangent line is touching the circle at exactly one dot. Here, and then over on the other picture, right here. Now, first thing for your notes. Question 1. On the circle below, draw 3 examples of lines or segments that are not tangent to the circle. I'll pause the video for you to do that. I'm going to draw some samples myself. Here is a line. This is not tangent to the circle, but because it touches the circle in 2 points. Here's another one. I'm going to draw a segment from the center out to the edge of the circle. That's not tangent to the circle. Even though it touches it in exactly 1 point, the rest of the segment is inside the circle. It's not like the 2 examples of tangents that we had up here above. And then for my final one, I'm going to draw a segment that goes from this dot to this dot. This is not a tangent line either. Now in question 2, we're asked to define a tangent line. So let's do that. Please copy this definition in your notes. A line is tangent to a circle, or another way to say that, a line is called a tangent line if it intersects the circle in exactly 1 point. Now number 3, draw a tangent line and a radius to the point of tangency. First, I'm going to draw a tangent line. I'm going to choose to draw it over here. So I'm drawing, and then it touches the circle in exactly 1 dot as it brushes by the edge. Here's my tangent line. Now I'm going to draw a radius from the center to that point where the tangent line intersected the circle. Right like that. Now question B. Describe the relationship between the tangent line and that radius. Well, what does it look like to you? To me, it looks like this is a 90-degree box. I think that those are perpendicular. So let's write that for question B. On the next page of the handout, I want to call your attention to the definition of diameter over here in the left margin. A diameter is a segment that contains the center of the circle and 2 endpoints on the circle. So if this is a circle, and that dot right there is the center, a diameter is any segment that goes all the way across the circle going through the center. One endpoint would be here, the other endpoint would be here. That is the diameter of the circle. There are an infinite number of those that could be drawn inside a circle. Next, look down just a little bit more on that page and take a look at the definition of a chord. A chord is a segment whose endpoints are points on a circle. Over here on the right side of the video, if I draw a circle and then I make a segment inside the circle that touches the circle in 2 spots, that is a chord. So here's a chord, here is another chord, here is another chord, and so on. Any segment whose endpoints are on the circle is called a chord. Next vocabulary word in this lesson is the word arc. An arc is part of a circle consisting of 2 points on the circle and the part of the circle between the points. Let's draw an example of this in this space on the video. So let's say we have a circle here. Right in the center is the dot that's the center of the circle. But let's choose any points on the circle itself. For example, this dot and this dot. An arc would be those dots and the part of the circle in between the dots, which I'm tracing here in black ink. That portion of the circle is called an arc. Let's go to the next page and look at the check your understanding questions. Number 9, on the figure below, draw a tangent line and a diameter to the point of tangent C. I'll pause the video for you to do that. And here's my answer. It didn't say where to draw the tangent line, so I'm going to choose to draw it over here to the left of the circle, so that when I draw past the circle, it just perfectly brushes up against a single dot on the circle. Here is my tangent line. And now a diameter has to go all the way across the circle. So that point right there, the point of tangency, I'm going to draw through the center and touch the other side at another dot. Here is my tangent line and my diameter. Now number 10, describe the relationship between these two things. Well, what angle do you think this is right here? It's a 90-degree angle. So these things are perpendicular. Number 11, Josie states that in some cases a chord can also be a tangent. Wyatt says that a chord can never be a tangent. Which person is correct? And it is Wyatt. Remember that on an earlier page we wrote down the definition of tangent. It intersects a circle in one point only. And we wrote down the definition of a chord. It has endpoints on the circle. It has two endpoints on the circle. So a chord cannot ever be a tangent. Last one, number 12. A farmer is standing at point X. Point X is 36 feet from the base of a cylindrical storage silo. So in this drawing, we're looking from the top down at a round silo where grain is stored. The farmer is standing over here to the side of that silo. Notice where the 36 is labeled in this triangle picture. Find the radius of the silo to the nearest tenth. So the radius has been labeled with the lowercase r. To do this, we need to use relationships that we have figured out this year. What is the angle right here where the radius meets the tangent? That's 90 degrees. We talked today that that would be perpendicular. Because of that, this is a right triangle, and we can use the Pythagorean theorem to find the answer. R squared plus 42 squared equals the hypotenuse squared. Now when we do the hypotenuse, we have to be very careful. Notice that from here to here is the 36. But that's not all of the hypotenuse. The hypotenuse also includes this dashed portion here, which is the radius of the circle. Remember, that was the letter R. So when we fill in the letter C, we're actually filling in R plus 36. No doubt you'll understand that an easy mistake is to simply use 36 for the letter C. Now let's solve this. So 42 to the second power is 1,764. And then over here on the right side, we have a binomial and we're squaring it. So we're going to use FOIL to do that. First, outer, inner, last. First we do r squared, and then we're going to have plus 72r, and then plus 36 squared. Let's figure that out. That's 1,296. So where did the 72r come from? That was the letter O and I in the word FOIL, the outer and inner. That's when I multiplied r times 36, which is 36r, and then did it again, r times 36, to get 36r. When you add those together, that's the 72r. You learned how to do that in Algebra 1 class, squaring a binomial. Okay, next step. Notice that on the left side there's an r squared, and on the right side there's an r squared. Subtraction will make the r squareds cancel away out of our equation. Now I'm going to subtract 1296 from both sides. On the right side, this cancels away, and the 72R is alone. On the left side, what is 1,764 subtract 1,296? It's 468. Final step, divide by 72 to get the letter R alone. We get R equals 6.5. In the problem, the word feet was used as our measurement for distance, and so we have figured out that the radius of the silo is 6.5 feet. To solve that problem, we used something we learned about circles, that the radius and the tangent are perpendicular. That's how I knew that this was a right triangle. Then I used what I knew about right triangles to figure out the unknown side. So in this lesson, we were learning some basic vocabulary about circles. We learned the word tangent. We learned the word chord. We learned a special kind of chord that goes all the way across the circle called diameter. And we also learned the word arc, although we didn't do any problems with the word arc yet.